Okay, this is 2, 3, and objective 6 and 7. Proving theorems. So we are going to prove 2 theorems in this packet. Let's do the warm-up. So stop the video, do this problem. It's one of those that you like, the number lines and coordinates. And come back. Okay, so hopefully you could do this. You have done enough of this that now you can do these things. So let's draw it. It says sketch a diagram and find. So let's do it. Coordinate of point L and X are 16 and 40. So let's just say L and X and 16 and 40 respectively. N is the midpoint of Lx. Here's the N. Y is the midpoint of Ln. Here's the Y. Sketch a diagram and find L. And the distance between L and N is half the distance between L and X. Between 16 and 40, the distance is 40 minus 16, so that will be 24. So that's the whole distance. So then this distance is half of that, so that's 12. So this is 12. The coordinate of N would be, this is 16 and distance is 12, so that would be 16 plus 12, which is 28. Okay, and then Ly, distance between L and Y is half of this, right, because it's the midpoint. So this would be 6. So that would be 6. And the coordinate of Y would be 16 plus 6. So that would be, what, 22? Okay. Hopefully you could do this. Okay, so we are here. We're going to review these 3 sections and we're going to have a quiz on next time. Okay, objective 1 through 7 were in these 3 sections, and we do 6 and 7 in 2, 3. Okay, so the objective 6 is use the midpoint theorem and the angle bisector. This is how I abbreviate it, midpoint and angle bisector theorem. I was supposed to write angle bisector here. Bisector theorem. Okay, let's look at the angle bisector. Oh, this is a midpoint theorem. Okay, so this one, the proof is all written out for you as an example. So let's go over this. If M is the midpoint of segment AB, then AM is 1/2 of AB and MB is 1/2 of AB. So that's the midpoint theorem. Okay, and the given is that M is the midpoint of AB. M is the midpoint of this segment. Then AM is 1/2 of the whole segment and MB is 1/2 of the whole segment. So that's what you're trying to prove. Which sounds obvious, but you have to prove it. That's what just math is. So M is the midpoint of AB, that's given. Okay, that means segment AM is congruent to segment MB, or AM, the distance, equal the distance MB. That's the definition of midpoint. Okay, if it's a midpoint, then it makes the 2 congruent segments, and if they are congruent, then they are same lengths. You can put this both in the same line and call it definition of midpoint. Okay. If you were to separate this into 2 lines, this would be a definition of midpoint, and then you can make this a definition of congruent segment. But it's fine to put both in the same line. Okay, AM plus MB equal AB, that's segment addition portrait, and AM plus AM equal AB. And what's happening here is that since AM is MB, you are substituting this into this equation to get this, right? Because MB equal AM, so AM plus AM. And then you can add these two to make it 2AM equal AB. So that's substitution property. Whenever you have a substitution property, I want you to write out which steps you're substituting into which one. So in this case, the step 2 is substituted into step 3, step 2 and 3. Now, from here, you divide both sides by 2 to get to AM equal 1/2 AB. That's division property of equality. And then MB equal 1/2 AB. The last step is substitution of this. So substitution of step 2 into this equation 5. Okay, and then you are done. Because you are supposed to do both of these as a proof. So this is the two conclusion lines. Okay. All right, so here it's just a practice on coming up with the justification or the reasons for these statements. You can do these 3 for homework. I think you can do this. And we are going to do this right now. Okay. If E is the midpoint of AF, then AE is congruent to EF. And that's very similar to this, right? That's the definition of midpoint. If E is a midpoint of AF, then AE is 1/2 of AF. That's what we just proven. So this is not definition of midpoint anymore. This is the midpoint theorem. So I need you to understand that if you are saying this in the proof line, the statement, then that's the reason you need for that line. If you're saying this in the statement for the proof, this is what you have to say for the reasons, not the definition of midpoint. If E is the midpoint of AF, then EC, the ray EC bisects the segment AF. Now, these things in the English words, you feel like they're saying the same thing, but in mathematics, in the proofs, these are 3 different things. If you're going to say this in the statement, then the reason have to be what? Definition of segment bisector. Okay. Which is different from definition of angle bisector. So you have to say, when you're saying bisector, you have to say either segment or angle. If EB bisects AF, so EB bisects AF, then E is the midpoint of AF. That's also a definition of segment bisector. Okay, if you notice, these two are converse of each other, right? So this is the hypothesis, and that's a conclusion for this one. And this, well, it changed EB to EC, but it's kind of same thing because it's bisecting. This could be EC, right? Then this is hypothesis, and that's conclusion. These are converse of each other. And since the conditional and converse are both true, you can use this as a definition. If you were to do if and only if, it would be E is midpoint of AF if and only if the ray EC bisects AF, or ray AC bisects AF if and only if E is the midpoint of AF. Okay, so that's why it's a definition of segment bisector. And we are going to do this one on next page, so we skip this one. And then the last one, BEC, angle BEC is congruent to CEF, so these two are congruent. Then ray EC is a bisector of BEF. Now, to be strictly speaking, I like to say angle bisector here, okay? Then EC is angle bisector of EBF, and that is a definition of angle bisector. Okay, again, if you flip this into converse, the ray EC is the angle bisector of angle BF if and only if the angle EBC is congruent to angle CEF. So since the definition converse is true, you can write it as biconditional if and only if. All right, so this is the angle bisector theorem. And what it says is, and then you have to complete this one, okay? So given BX is a bisector of ABC, prove that angle ABX is 1/2 of ABC, and angle XBC is 1/2 of ABC. Okay, it's very similar to the midpoint theorem. Okay, so BX is a bisector of ABC, that's given. Okay, and angle ABX is congruent to angle XBC. And if the angles are congruent, then measure of angles are the same. Measure of angle XBC. And that would be what? That's definition of angle bisector. Okay. And measure of angle ABX plus measure of angle XBC equal measure of angle ABC. And that is angle addition postulate. Now, remember, you can add and then make it equal only if these are numerical values, and that's why you had to say both here, the congruent and the measure. You cannot add just the angles here, okay? You have to change to measure. All right, and measure of angle ABX plus measure of angle ABX equal measure of angle ABC. So same thing that happened in the midpoint theorem, we are substituting this one into here to make it a ABX and ABX. And then you add together to make it 2 measure of angle ABX equal measure of angle ABC. So that's this substitution. And step. So we did 2 into 3. Okay, and then the 5 from here, you divide in both sides by 2. So division property of equality. And then in the end, you are substituting this one into here to make it XBC. So that's a step 2 and 5. Okay. And then now we are using this theorem to solve this problem. So let's do this one. So angle SW bisects angle RST. So RST and SW bisects this angle, and RST is 72. So that's 72. So that means this is bisecting, so this is 36, and this is also 36. Okay, and SZ bisects RSW. So the SZ bisects this, so this is 18, and that's 18, because that was 36. And SR bisects NSW. So W and S, so N is over here. Okay, so SR bisects NSW, and this is the bisector of this angle. So this is 36, so this should be 36. Okay, and sketch diagram and find the measure of angle RSZ. RSZ is 18, and measure of angle NSZ would be 36 plus 18, right? NSZ 36 plus 18 is 54 degrees. That's okay. And here is using theorem in the proof. Okay, in addition to postulates and definitions, theorems may be used to justify steps in a proof. Notice the use of angle bisector theorem in example 2. All right, so that's a given. These 3 are given, and that's to prove. Okay, I want you to try this. I want you to try doing this reasons for homework. Okay, and we're going to do objective 7 in class, and the rest of the program in the class. Okay, we are done.